Did you know that stackexchange has a rich REST API? Today we're going to access two REST endpoints to determine the 5 most popular stackexchange sites. So first, here's some general information regarding authentication, JSON, compression, and then there are two very interesting pieces of information for the purposes of this video. So first, we are not allowed to make, I don't know, hundreds of requests per second. Then we are going to, the server is going to stop us from doing that. And we shouldn't make the same request over and over and over again, because the information won't change from 1 minute to the next. So for the purposes of this video, we really shouldn't make the same request more than once, ideally. Okay, because we also don't want to wait for it all the time. Okay, and then the endpoints themselves, you can see them listed here. There's quite a lot of them. And down at the bottom is the first endpoint that's interesting for us. Here you can see the complete URL. Let's see, let's do it like this. I'm sorry, here you can see the complete URL. And what you can see is we get a JSON response with an object containing 4 keys. And here you can see that I already used up quite some quota in preparation of this video. So after 180 more requests, the server won't accept any more requests from us for, I don't know, 1,000 minutes or something the last time I tried. So yeah, don't make too many requests. Okay, then items is an array, and inside that array there's an object for each stackexchange site. For example, the first one at index 0 is for Stack Overflow itself. Let's close this one up. And you can see one interesting key, the API site parameter Stack Overflow. Why is that key so interesting to us? Because there's another endpoint called info, and the endpoint info has a query parameter site where you can paste that API site parameter and then get information for different websites, right? So this would be the information for Stack Overflow, new active users, I don't know in which time frame, total users about 10 million batches per minute, and so on. Okay, and I've already used 5 more requests. That's interesting. Okay, or unnerving rather. So maybe one more example. Let's close Stack Overflow, which would be the next one. The next one would be server fault. So what would happen if we put server fault in here? Does it also have 10 million users? No, rather it has, how many is this? 400,000. Okay, so Stack Overflow is definitely more popular than server fault, not surprisingly. Okay, so how would we access those APIs? Let's see, this is the first one, this is the second one. Let's close these guys. How would we access those two? I'm sorry, I wanted this one. How would we access these two guys from within Clojure? So let's see, let's switch to the environment here. And did I already evaluate those guys? Yeah, okay. So I stored the two important URLs inside two vars, sites and info, there you can see. And now we have to make an HTTP request, right? So we can do it with our beloved clj-http library. And inside the client namespace, there's a nice get function responsible for get requests. And then we simply provide the URL. Let's see what happens then. Okay, so here you can see a large HTTP response comes back. Yeah, maybe let's immediately pretty print it so we can see a bit better what happens. And you notice maybe that it takes half a second or maybe a second for the request to get through. So that's one more incentive for us to maybe cache the results on our computer as well. Okay, right, so this is all HTTP stuff. Where's the actual content? There we go. The actual content is in the body. So if we say please access the body, then we wait another second and then you can see the body. Okay, so maybe before we continue, let's think about caching these requests on our own computer. So there's a cool function called memoize. Let's see how it's documented. Returns a memoized version of a referentially transparent function. So usually you should only do this with functions that, given the same input, will always return the same output, like mathematical functions like square or square root or sine, cosine, whatever. For the purposes of this video, it's okay to memoize these HTTP requests because the results won't differ over time in a manner that will impact us. Okay, so this client get function, you see we only provide one parameter, the function. So we can simply say we want to memoize the client get function, and the result of that memoization is the memoized function, and we have to store that in a var. Let's call it memo get. Okay, let's evaluate it. Then let's use it over here. Get. Let's evaluate that guy. Again, takes about a second, but now let me do something with the results. You can see the difference. If I now execute it again, maybe the pprint is what takes up most of the time. Could also be. Okay, but now we won't use up our precious quota. Okay. Right, you can see that the body is just a large string containing JSON, right? So here you can see the first key, then comes after the colon the first value, which is an array, and so on. Right, so ideally I would like to see this information as, or parse it into a Clojure map, and we can achieve that by saying, let's see, as JSON, I think that's the correct syntax. Let's see. Yeah, there we go. Okay, so right at the bottom there should be our quota. Yeah, 168, so almost at 50% now. Okay, so now let's look inside the items array. Okay, there we go. And yeah, here's our API side parameter for Stack Overflow. And if we drilled deeper to the next guy, can we see the next guy? Here, there would be server fault. So ideally, I would want to only look up the API side parameter from each one of those objects, right? And for that, we can use our good old friend, the map function. I only want to see the API side parameter, map that function over all the maps inside the array or vector in this case, and then we should see something interesting. Yeah, there we go. That's all the websites or all the API side parameters. Okay, cool. So maybe we should store them in a var. Let's call it, I don't know, all site parameters, and then put that one over here, and then we don't need this guy. Did I close everything? No. Okay. Let's see if we did everything correctly. All site parameters. Okay, I did something wrong. I forgot an S over here. There we go. Okay, scrolled a bit weirdly. There we go. Okay, cool. So now we already know all the site parameters. Now we can start playing with the second URL. So let's start again out by a concrete example. Let's say memo get, and now I have to concatenate the info with one concrete example. Let's say Stack Overflow, why not? And I also want to get that as JSON, the body. Let's see what happens now. Okay, okay, let's immediately go to our favorite macro. Don't forget to close it and look at the body. And you can see we have instant results because we already had the result memoized. Okay, so there's also an items key, and what's inside that? That's an array. How many items are in that array? Yeah, there's only one. So that's some weird aspect of the Stack Exchange API that you, for this particular endpoint, you always get an array which has one element for consistency's sake, I suppose. I don't know. Okay, right, let's pretty print that guy. Let's see. Yeah, okay. So if we want to measure popularity, one obvious example would be to say the total users, right? How many users are on the website. That would be the 10 million for the Stack Overflow. Okay, so let's say total users. Oh, did I do something wrong? Oh, I didn't go into the first area and then total users. Yeah, okay, and then we don't need the pretty print, of course. Okay. All right. Let's first get the entire information, because I want to call this function site info for a particular site parameter, and then replace the Stack Overflow with that site parameter. Okay, what did I do wrong? This parent doesn't belong here, it belongs there. Okay. Let's first see again if we get the same result for Stack Overflow. Okay, there are, let's see, pretty print. Yeah, total users 10 million, and now just to make sure it really works, I don't know, so do we get a different result? Yeah. Okay. I always test this with two arguments just in case I forgot to put the real parameter in here instead of the constant. Okay. Right. So this site info function gives us all the information, but it doesn't give us the name of the website itself or the API parameter itself. So later, if we want to look at this again, we don't really remember what site this belongs to, and most of the information isn't really interesting to us anyway. So let's maybe write a function. Let's call it pick popularity for an API site parameter that should return an object. Object in JavaScript terms. This is a map in Clojure that has a name and that has a popularity. Okay. And the name should be the API site parameter itself. And this one should be the total users from the site info of the API site parameter, right? So total users of site info given the API site parameter. Okay, and then we can move this guy over here. Okay, now let's see if this works for the 10 million case again. So Stack Overflow. There we go. Stack Overflow has a popularity of 10 million because we said the popularity is the total users. If you decide that you want to pick something else, like, I don't know, questions per minute asked or something, you can replace this here in line 27. Okay, now of course we don't want to just see the popularity of Stack Overflow. We want to see it for all the websites. Let's see, so that would be all site parameters. Let me get rid of this line so we don't get confused. So you remember this is the list of 30 site parameters, and then we want to map the pick popularity function over all of those, and let's see what happens here. So sometimes this works, sometimes the server responds with, hey, too many requests per second or something. Let's see if we get an error message or not. But you see it takes some time. Okay, this time it worked. Okay, okay, let's pretty print this again because it's way too long. There we go. Okay, cool. Now, if we want to determine the top 5, you see that this is not really sorted, right? So Stack Overflow 10 million on on the first place. So this seems to be correct. But here you can see in the middle is a 7,000. Above that is 147,000. Below that is 139,000. So it's definitely not sorted. So let's sort it. So there's this sort by function where we can simply say which of the keys is interesting for us. That would be the popularity. And now you can see it's sorted in the wrong order, right? Because normally you sort ascending, you start with the low numbers and work your way up to the high numbers. But we can, with an addition of one more argument, we can say please sort the other way around. And now you can see Stack Overflow is back on the first spot. Okay, but that's still more than 5. So how would we say we only want to see the first 5 results? That would be take 5 of those. And there we go. Right. Okay, so in case this doesn't work for you, so sometimes we simply fire too many requests and then the server is not very happy with us. So a solution to that would be to say, let's write a slow get function that takes an arbitrary amount of arguments. And the first thing it does is it sleeps for, sleep for 100 milliseconds. So we limit our number of requests to 10 per second. And then we apply the normal get function to the arguments that we provided to the slow get function. Okay. And then here, of course, you would memoize the slow get function. Okay. So maybe let's test this program one more time. Let's run everything from scratch. This should take, I don't know, maybe 3 seconds at minimum, because the 30 requests will be, yeah, you can see it's already taking longer. So maybe there's some server-side throttling going on without giving an error. There we go. Okay, and just so you can see that the memoization still works. So if I want to see the top 7, I immediately get the answer. Okay, cool. Right, so maybe a quick wrap up. So you just saw this. So I want to define a slow get function that before it does the actual request sleeps for 100 milliseconds. So we limit ourselves to at most 10 requests per second. Then we memoize that function. So if we request the same information again, we don't even go to the server. So this is a really cool function. You should really look at the implementation. It's mind-blowing how simple it is. Okay, then we defined a var, which should contain all the site parameters for all these Stack Exchange sites. How did we do that? First, we did a normal or memoized slow request to the site's URL, which you can see over here. We wanted the response not to be a simple JSON string, but we wanted the JSON to be decoded, so we have a Clojure map. Then we peeked into the body of the HTTP request. Then we looked at the items array, and the only information that was interesting to us for all the maps in the items array was the site parameter. Okay, and here we simply tested that we really get the desired result. Okay, so what did we do next? Then we said, well, for a particular API site parameter like Stack Overflow or server fault or super user, I want to access the second endpoint. And then we again look at the body, look at the items. And since there's only one item really, we immediately get to the first element. And then we have all the information for one particular website, which is about a dozen statistical interesting numbers. Okay, then we said, well, we're not really interested in all of those numbers. We are primarily interested in the number of total users, and we name that the popularity of the site, and the API site parameter we simply rename to name. So this function gives us an object with 2 properties. When I say object, I really mean map. Been doing too much JavaScript lately. Okay, then we take our lovely 30 site parameters, map the pick popularity function over it. So now we have 30 of those interesting statistics. Then we say sort them by popularity and only take the first 5. Right? And the pretty print is just so that they are nicely aligned under each other. Yeah, and that's all there is to it really. So for the homework, why don't you look at the memoize function first? Try to understand what the documentation says. Maybe think a little bit about how it is achieved, how would you implement it yourself, and then look at the implementation that starts down here. It's really cool. Let me show it to you first. See how short it is. It fits in about 10 lines. That's really cool.